Hello Year 12 and welcome to what should be the fourth video here for our second topic for exercise 304, linear functions. Now when we talk about linear things in mathematics, typically we mean a straight line. Okay, so we're talking about some sort of function, some sort of graph that has a straight line. Now the equation of such a function should take this form: y equals mx plus b. If it's not expressed in such a way, we should be able to rearrange it such that it is. Now, when we arrange it like this, that x has to have a power of 1. It can't be 1 over x, it can't be xy, it can't be x squared, or the square root of x, or any of those things. And the same can be said for y. Now, m and b are numbers, right? M is a coefficient and b is a constant. Okay, but they're numbers, and it's important that we can find those. Now, what can be particularly challenging about linear functions is having a set of numbers, a set of data, and finding the equation that describes the relationship between two variables. Okay, so what I want to go from maybe a table of values or a graph to an equation like this. The great advantage of an equation like this is that I can use this then to find any other matching values that I like. Okay, I can substitute into this once I've got an equation. I've got a formula as such, and I can use that to find all sorts of other things. So this is a linear function in the form y equals mx plus b. M is the gradient, and b is the y-intercept. It becomes a linear model if we're talking about trying to match it to some real-life situation. So, two options here. If we have a graph, we need to find where it crosses the vertical axis, and that's this thing called b, the y-intercept. We also need to find the gradient, and we're going to do that by choosing any 2 points on the graph. Right, any 2 points on that line, finding the change in height between those points and dividing it by the change in horizontal position. Okay, the change in height divided by the change in horizontal position, or rise over run, or the change in dependent divided by change in independent. Right, those things there tell us the gradient. Alternatively, we might not have a graph, we might have a table of values, look something like this. Now, easy enough to find the gradient here because each of these sort of pairs of values represent a point on that line, if you like, on the graph. So, change in the dependent, right, divided by the change in the independent tells us the gradient. What I need to do then, because I don't necessarily have the y-intercept, is take this formula y equals mx plus b, take any of these pairs of coordinates, substitute in the m that we've calculated, a y and an x from this table. Right, it can't be the 2 and 11, for example. Right, it would have to be the 2 and the 9, or the 6 and 11, or so on. Substitute those in and solve for b. Once I've got b, and we've already calculated m, then I rewrite this again without substituting the y and x, leaving those as pronumerals, and I get y equals mx plus b, the equation of my function. Now, enough talking, let's have a look at an example. Here I have a table of values, and I need to find the equation of the line of that linear function that represents this relationship. So first of all, we need to find m, the gradient. So m equals, right, I'm going to use this pair and this pair. I'm going to call this x1, this x2, y1 and y2. You don't need to label it like that, but it helps to keep it in mind perhaps. So I need the change in this dependent variable. So I've got 3 minus 1, right, the difference between these two numbers, the second one minus the first, divided by the same thing here, the second minus the first, divided by 2 minus 1. And that, of course, gives me 2 over 1. So my gradient is 2. I can actually, in this case here, now I did say we substitute this into y equals mx plus b, right? Put any value of x and y in there. But we do have a special case here, right? See, because x equals 0, that means my y-intercept is the -1. That's what the y-intercept is the y value that goes with an x equals 0. You don't always get that, and so look, just for the sake of practice, let's see how that would work. Right, let's substitute in, for example, this 2, 3 coordinate, or coordinates, to see how we go. Let m equal 2, y equals 3, x equals 2. Therefore 3 equals 2 by 2 plus b. Therefore 3 equals 4 plus b. Therefore b equals -1. See, right, there's our -1. We get the same thing if we substitute 1, 1 in here as well. Anyway, okay, well that's not a 6, that's a b. Therefore my equation is y equals, right, we said m equals 2, y equals 2x minus 1. You're really not done. Even if you calculate m here and b there, you're not going to get full marks if you stop without writing the equation, because you're really careful, it does say find the equation. It doesn't say find the gradient and y-intercept. Moving along now to our next example. I have another table. It's a bit of a model this time because we have volume and cost. Right. And we want to find, first of all, this linear formula. Now, we definitely don't have the 0 in the top line here, so we are going to have to go through those steps. Right, it's nice to choose numbers that that subtract neatly. I don't know how well that's going to happen here, but I think I will go with, I'm going to use these ones here, just because we get the 20 and the 15, the 20 and the 50. Okay, so my gradient equals, now it's the bottom one here, so 134.5 minus 109 over 50 minus 20. Now I want to be careful and don't make a mistake, so I'm going to pull out the calculator here. I've got my 134.5 minus the 109. Okay, that's the top, divided by, now I'm fairly happy, 50 minus 20 is 30. And there we go, my gradient is 0.85. Okay, so that's part way done. I suppose that's a third of it done. Now I need to find the y-intercept. So I'm going to say let m equals 0.85, x equals, let's go with this one, the whole numbers, x equals 20, and y equals 109. Now, of course, we don't have x's and y's, but I'm just going to work with those for the time being like this, okay? When we write our final equation, we'll replace x with v and y with c, but far simpler to work with these conventions. Therefore, 109 equals 0.85 times 20 plus b. Therefore, b equals 109 minus 0.85 by 20. Okay, now 0.85 times 20 is 8.5 times 2 is 17. So 109 minus 17. Oh, geez, you know what? It really is just one of those days where I don't want to do it. Look at that, 2 calculators going. So 109 minus 17 equals 92. So there we go. And a quick inspection, does that look like that's going to be about right? Well, if we kept going down here till we got to a 0, it's not crazy. Now, finally, okay, we've done all the hard work there, but we do need to write this as, okay, my cost, because remember it's like y equals, so it's the dependent variable there on the bottom. My cost is equal to 0.85 V plus 92. Okay, I can check that answer with my calculator here, and I can look at something else. Come on, calculator, show me how that works. Hey, calculator, where are you? Here we go. Clear it away. Let's try it with this 38,124.3. You know, they're sort of fresh numbers. We haven't looked at them before. So let's try 0.85 times my V, that's 38, equals plus the 92 and 124.3. Okay, not an infallible check, but pretty good. Rightio. Now, what does the gradient represent in this particular case? Well, we've got to read this a little bit careful. The cost of water for different volumes. Well, it must be, right, the gradient shows how much it changes sort of per unit. So that means for every kiloliter, how much it costs. So it is the cost in dollars, per kiloliter. What does the vertical intercept represent in this particular case? Well, the vertical intercept can be something like the initial cost, something like that. So what that would be in terms of your water bill, right, it will be something like an access cost. An access fee, or the cost before any water usage. Okay, sort of the minimum you're going to have to pay. And what is the independent variable? Okay, the independent is the horizontal axis, right? It's like the x goes across, x looks like a cross, another name for perennial. What does it represent in this case? So it's the top line, it's the horizontal axis on a graph. That's what would normally be the x. Right, it's independent because we make up the x's. Y depends on x. We use x to find y. So, my independent variable is v. And what does it represent? The volume of water used. Okay. And I think that's us done. Rightio. That'll do us for now. We'll look at direct linear variation in our next video. I'll see you in class.